Hi everyone and welcome to the stream. I just wanted to put together a quick review of some things we covered in class before. This is about permutations. So we'll get started right away. A permutation, as we've discussed, is an ordered arrangement of some collection of objects. So for example, if we wanted to list all of the permutations of the objects x, y, and z, then we could just start putting them in order. So the first order would be to put them in order x, y, z. But then we could maybe switch the y and the z and have x, z, y. We could start with y instead, and then we would have y and maybe then x and z. Or we could have y and then z and x. And finally, we could start with z, have x and then y. Or we could have z and then y and x. And if we think about it a little bit, we can probably convince ourselves that this is all of the permutations there are, all of the orders in which we could place these three objects. So we would say then, okay, we've done a listing and there are 6 orderings, or 6 arrangements, or 6 permutations. Now, the thing that we're going to find most useful here is to count how many permutations a collection of objects can possibly have. That's interesting in and of itself, maybe, but it's going to be really useful when we're trying to calculate probabilities of certain events happening. This is going to be a very useful tool. But we can't just go listing them out, because the list of possible permutations gets very, very long when you have more than 3 or 4 or 5 objects. And once you're listing them, you can't really be sure that you've gotten everything. So we need a more systematic way to think about it. Luckily, there is one. So if we want to count how many permutations there are, then we imagine that there are a certain number of spots where we can place these objects. So instead of thinking about the arrangements themselves, we think about how we would make an arrangement by first having one spot to put the first thing, and then another spot to put the second thing, and so on. And we're going to count how many choices we have for objects to put in each of those spots. And then finally, we're going to multiply the results. So we're going to start by, so let's take an example here. Suppose we had 4 objects that we needed to arrange, and we wanted to count how many ways we could do that. So we would imagine that we would have 4 spots, right? So four spots for the objects. And then the question is, for the first spot, how many options do we have? Well, there's 4 objects, so there's 4 possible things we could put in that first spot. For the second spot, well, one of the objects has already been placed in the first spot, so that leaves 3 possible objects that could go in the second spot. And then 2 objects have been used up. That leaves us with 2 more that could go in the third spot. And finally, where our choice is forced, for the last spot, there's only 1 more option. So we had 4 choices, 3 choices, 2 choices, then 1 choice. Altogether, there are the number of ways we could have made those decisions is the product of these things. So we need to multiply each of these together. So 4 times 3 times 2 times 1 will be equal to 24. 24 permutations. All right, now this pattern of highest number times next highest number times next highest number and just reducing it 1 each time is repeated for any number of objects when we are counting the permutations. So this gives us a general rule, if I can do it. There's our general rule. If we have n objects, then the number of permutations is n factorial. So we'll see in the example what factorial is. Remember, that by definition, that's just start with the number n, whatever it happens to be, and then multiply it by all of the lower numbers. You just move down 1 and multiply, multiply, multiply. So 10 times 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1, if it was 10 factorial, and so on. So that allows us to quickly count this without having to think too hard about what we're up to. So for example, if we have 4 objects, the number of permutations would be 4 factorial. 4 factorial is 4 times 3 times 2 times 1, and that gives us 24, which is the same as what we had before. If there were 6 objects, then our number of permutations would be 6 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Or if you'll notice, you could also write this as 6 times 5 times 4 factorial. Either way, we will get that this result is 720. And then finally, if we had 7 objects, there would be 7 factorial. That would be 7 times 6 times 5 times 4 times 3 times 2 times 1. A faster way to calculate that would be 7 times 6 factorial, right? Because if you notice, this remainder here, that's 6 factorial. So you just have the 7 times 6 factorial. We already know what 6 factorial is, so this is 7 times 720. And that turns out to be 5,040. All right, that's all I wanted to let you know there. So just a quick review of how we count permutations. Look out for the next video, which will cover how to count combinations, which are a little bit more involved, but use this tool of the factorial and the permutations in order to do the calculation. All right, hope it was useful.